Okay, people, hold it down. End of the world, take one. Anytime, Sydney.
At first, it looks like kind of a fireball. It grows bigger and bigger by the minute. Soon, it seems to be larger than the sun. People are frozen to the spot with their eyes glued to the sky. They haven't realized yet they have to run for their lives. Not that it's going to help. The asteroid slams into the planet with enormous force. It doesn't stop moving until it gets through the crust to a depth of several miles. Thousands of cubic miles of solid rock instantly turn into vapor. Everything and everyone close enough to see the crash don't live longer than a few seconds. The ground around the impact crater is covered with thousands of feet of hot ash, grit, and rubble. Mere seconds after the collision, grass, trees, and shrubbery for many miles away burst into flames. But that's not all. The crash sets off a series of natural disasters, like tsunamis. What didn't burn down within the first several minutes gets flooded. In some places, tsunami waves are higher than 1,000 feet. Earthquakes start to shake the planet. Less than an hour after the asteroid crashed into the planet, a gust of wind whips through the world. Its speed is more than 600 miles per hour. The hurricane flattens down everything that is standing and scatters debris for miles around. A bit farther away from the impact zone, the sky is starting to darken. That's why beautiful shooting stars seem even brighter. But those aren't stars. That's debris raining back on the planet. They re-enter Earth's atmosphere glowing ominous red because of the infrared radiation. These are just the first hours after the crash, but the sky is almost completely black. By the time it begins to get lighter, there's no life on the planet. The ash is still in the air. When it rains, the water gets highly acidic. Fires keep raging. They produce tons of toxins that destroy the ozone layer. Earth loses its last shield against the radiation from the sun.
Okay, I don't like that one. Too much doom and gloom. What else we got?
Well, or the end of the world could look quite different. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. The climate all over the planet starts getting colder and colder. It becomes impossible to live close to the poles. All life gathers near the equator. Quite soon, half of the planet turns into an icy desert. There's a lack of food and other resources. It's getting darker and darker. There's not enough light for plants to get energy. They wither, and animals that used to feed on them can't find food and go extinct. The farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth gets too far away from its main source of light and heat. It turns into a lifeless piece of rock covered with a thick layer of ice.
Nah, I don't like that ending either. Leaves me cold. Anything else?
Or the sun might expand and turn into a red giant. If it happens, it'll change the entire habitable zone of the solar system. It starts when our star runs out of the hydrogen in its core. This triggers several reactions. In the end, the core heats up and gets denser, which makes the sun way larger. During this transformation, the sun swallows Venus, Mercury, and Earth. The expanding star engulfs our planet even before it reaches the tip of its giant red phase. It still has around 500,000 years to grow. As soon as Earth is inside the sun's atmosphere, its orbit changes. The planet spirals inward, inside the star's raging heat. But no one and nothing is around to witness it. Long before that, the sun evaporates all the oceans on our planet. In the end, Earth becomes molten. Molten, huh? Nah, that's too hot to try. Try again. Okay. Or it might be something vastly different. People all over the world wake up in the middle of the night. It's as light as in the morning, but it's not sunlight. The skies are illuminated with countless auroras, red, green, purple. They appear even in the regions where no one has seen them before, like the Bahamas, Jamaica, or Hawaii. The sun is a gigantic, constantly changing ball of burning gases. Every once in a while, it spews out bursts of energy. Those are solar flares. They are often accompanied by coronal mass ejections. So, this time, the Sun has produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Waves of charged particles slam into Earth's atmosphere. The planet's magnetic field isn't powerful enough to stop this. It gives way, and the storm hits Earth, causing havoc. It starts by disrupting GPS and knocking out satellites. After that, the storm interferes with satellite communications. But one of the worst consequences is connected with power grids. Power surges caused by the particles coming from the Sun damage giant transformers. Earth is left without electricity for years. There's no light, no computers, no phones. Water supply systems are out of order. There's no food in supermarkets. There's no electricity, and people can't reboot the already broken power grids. Wildlife takes over the planet, creating some kind of a post-apocalyptic world.
Yeah, I think we should let the monkeys run things for a while. They can't do any worse. Alright, what else?
Ooh, if you had the gamma ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, then disappear again. Those flashes are gamma ray bursts. One of them might wipe out Earth's atmosphere. The flash that's going to ruin our planet was born in a faraway galaxy where two collapsed stars merged. It's immensely powerful. It carries 10 quadrillion, which is 1 followed by 16 zeros, times as much energy as our Sun. When the burst is 1,000 light-years away from Earth, it's already shining as bright as our Sun. Our planet's atmosphere is trying to protect us once the burst comes too close. But this shield doesn't last. The radiation is so powerful that it literally cooks the atmosphere. It creates nitrogen oxides that destroy the ozone layer. Without this layer, ultraviolet rays coming from the Sun hit Earth's surface at full force. They wipe out tiny plankton in the ocean. These plankton produce from 50 to 70% of all oxygen on our planet. They disappear, and soon there's a severe lack of oxygen. Terrestrial life vanishes first. After that, living creatures start to disappear from seas and oceans. In the end, the heat and ultraviolet light coming from the Sun turns the planet into a huge chunk of barren rock.
Never mind, I don't like any of these. Let's just keep the Earth the way it is, okay? Hey, Sydney, why don't we blow up Mars or something?
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope. Not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
A deep, deep orange sunset. Epic. You're on the deck of a cruise liner somewhere in the Atlantic. The sun dips slowly, merging with the water on the horizon. Next to it, you can see another circle. It's huge. It looks more like a new planet or a second sun, but this sphere's located on Earth. It's a balloon. Humans have been inflating it for months, and in just a few weeks, it'll be the size of our planet. Nobody knows who exactly came up with this crazy idea. Probably somebody from Brightside. It's the year 2121. People live longer and have better lives. At some point, they start to come up with weird and wacky things, not just useful ones. Hey, let's make a lake with boiling oil where we can fry potatoes 24/7. Or, what if we build a huge frozen city just for penguins? Someone suggests creating a machine that can put your consciousness into a shark or a goldfish, whatever sea creature you want, just to see what it would feel like. A couple of guys even decide to make the switch permanent. Sounds fishy to me. People discover more of outer space and create incredible, life-changing medical tech. But sometimes, humanity just wants to have fun. One day, a scientist decides to inflate a balloon the size of our planet and pop it, just to see what had happened. People are excited. It would definitely look awesome, and the pop would be insane. These kind of strange ideas pop up all the time these days. The economy, tech, agriculture, everything's developed so much. That means there's plenty of money lying around to spend on whatever's the weirdest idea at the time. The main thing now is to do stuff that's fun. And as soon as this idea comes up, billionaires around the world start throwing money at it. Who wouldn't want their name associated with just about the coolest project ever? On what looks like any normal day, scientists gather in an underground lab to talk materials. Why an underground lab? Because it's awesome! After 10 minutes, it becomes clear that there's no substance in the world that could stretch that much. So they decide to create one. Perpetual rubber. They come up with a sweet plan. They just can't build a deflated balloon the size of a continent and then slowly inflate it. That would be ridiculous. Wait, are there magnitudes of ridiculous? It's getting pretty high here. Instead, scientists decide to make a ball of rubber about the size of an SUV. Then, over the course of a whole year, they'd blow a strong stream of air into it until it was the size of Earth. Perpetual rubber can stretch forever and never tears. The rubber reacts with oxygen to divide and expand without getting popped too early. How lame would it be if it got snagged on a skyscraper and... The coolest thing about perpetual rubber is that if you hit it with a pencil or fork or whatever, it won't tear. It'll actually envelop whatever you push into it. So if we're talking about something bigger, like a car or a ship, it'll be a sort of bumper car situation. A little impact, but no biggie. Finally, months of hard work and $300 billion later, scientists unveil their masterpiece. And it kind of looks like a car-sized rock. Except it's orange for some reason, don't ask me why. The experiment begins in the most remote part of the Pacific Ocean, on an artificially created island. Here's where it gets more ridiculous. Interesting. While half the scientists are messing around with rubber, The other half were busy building the world's biggest turbine, a turbine strong enough to pump air into the largest balloon of all time. The turbine extracts oxygen out of, well, air, heats it, and pushes it into the ball of rubber. Sounds simple enough, right? Not really. This turbine eats up energy like me at a Sunday buffet. You know, the kind with prime rib, shrimp and seafood, all kinds of pasta, and a dessert bar so big you can't see the end of it, and oops, I got carried away there. Anyway, the turbine, it takes a whole team of solar, wind, and wave-powered generators to make it run. The final countdown begins. 10, 9, about 100 people grab the rubber ball from all sides and start to stretch it out over the mouth of the turbine. 8, 7, after fastening it to the turbine, it's helicopter time. 4 huge choppers grab hold of the rubber and start to stretch it up into the sky. 6, 5, 4, the rubber's stretching out beautifully. This thing actually might work. 3, 2, 1, launch. Somebody flips the switch and the turbine turns on. Whoosh! The turbine gathers speed and starts to pump oxygen directly into the outstretched rubber. After just a few days, the ball's already bigger than the island itself. From far away, it already starts to look like another planet or sun. Photographers go nuts. Every day, the ball gets bigger and bigger. Its edges reach the nearest coastal cities. Every morning, people come out of their homes and watch an orange rubber ball block out part of the sky. The turbine pumps oxygen into the balloon 24/7, and pretty soon it starts to float up ever so slightly. Next to the island, it becomes difficult to breathe. And what's going to happen when all our oxygen is inside that giant balloon? Whoops, the scientists didn't think that far ahead. Luckily, it's 2021, so tech moves pretty quickly to come up with a solution. Engineers submerge billions of tons of 3D printed phytoplankton and seaweed into the Pacific Ocean. These organisms are some of the Earth's main suppliers of clean air. They make oxygen the same way trees and plants do. By now, people are already used to walking the streets, watching the endless rubber sky. At first, it's all fun and selfies. Then, international flights over the Pacific start getting canceled or rerouted. It's actually faster to go from Beijing to LA by going the other way around the world on a bunch of ultra-high-speed underground trains. The higher the balloon rises, the faster it inflates. Something about the difference between internal and external pressure on the balloon. Basically now, the turbine doesn't eat up as much juice as before, which is good because it's the most energy-intensive piece of equipment humanity's ever built. After a few more months, low-flying satellites start to crash into the ball and gently bounce off unharmed. There are only a few days left before P-Day, the day everyone gets to witness the greatest pop of all time. Inside the balloon, something crazy's happening. The simplest forms of life are starting to take shape. And there's something these organisms and humanity have in common. We also live in a universe that's constantly expanding. Maybe the universe is just one big balloon, created by some cosmic race that loves big bangs. Ooh, hope they don't get the urge to pop it. The balloon rises higher than ever into the sky, and it's time for the final step. The turbine switches off, and the balloon is sealed shut. The Pacific winds blow the balloon east. It flies over megacities, forests, canyons, and floats low enough to the ground that people can even climb up on the roof and feel the ball with their hands. Some brave, or crazy people, pack on the layers, strap on a parachute, and put on special rubber climbing gloves. They scramble up the side of the balloon until they reach the top. It's a sky-high monster trampoline. When they get enough viral views, they run, jump, and open their parachutes. When it rains, the balloon deflects all the droplets into a single massive stream of water. You do not want to get a faceful of that. But that's not the worst part. The Earth's magnetic field gets disrupted, and the 3D printed phytoplankton just can't produce enough oxygen anymore. People find it difficult to breathe, but everyone agrees this thing was totally worth it. Animals go mad, and birds get super confused and start migrating to random parts of the globe. The sphere is slowly breaking away from the Earth's atmosphere. It's about to go into space. The live feed from the International Space Station confirms it. The balloon is the same size as Earth. Let's do it! It's time to pop this thing before it starts playing interplanetary pinball. Humanity holds its breath. The penguins in the ice city look up into the sky and fall backwards uncontrollably. The people that decide to turn into sharks and stuff poke their heads out of the water. Everyone's waiting. To pop it, scientists use a powerful laser. It's the big moment. Let's take a second. Big deep breaths. Okay, go time. The laser fires up and blasts a liquid hot stream of light particles directly at the balloon. The heat is palpable. The rubber starts to change color. It's going to burst open any second. Wait, this could end badly. Who cares? A huge amount of oxygen bursts into the Earth's atmosphere. It wipes away the clouds, leaving a perfect blue sky. But the most impressive thing is the sound. It just isn't. Everybody was jazzed up for an epic sound explosion. Nothing. Maybe a little... But that was it. Said some guy. I like the shark thing better.